In this video, we're talking about least common multiples. And just recall that a least common multiple between two or more numbers is the smallest number that all of those is the smallest multiple that all of those numbers go into. Okay, so the two numbers, for example, that we're talking about, 8 and 14, those will be factors of whatever number we find that is going to be in common. If you had viewed the last video, we used a trial and error method to find the least common multiple of 8 and 14. Here we're going to use a method by the prime factorization. And so we're going to take the prime factorization of both of these numbers. So step 1, find the prime factorization. In that case, we have 8 here. 8 is divisible by 2 and is 2 times 4. 4 is not prime, and so we have to that can be split into 2 times 2. Now all the 2's are prime, and so we want to count those and multiply them together. So this is 2 times 2 times 2, or 2 cubed. And now if you have no experience with exponents, you may want to go look those up, because this is going to make it the easier way to do this. And so I'm just going to write that number down here, just 2 to the third. We're going to turn around and do the same thing for 14. We're going to split that up. It is even. It's divisible by 2, and it's 2 times 7. Both 2 and 7 are prime. And so what I'm going to do is I'm going to carry that down so that's even with my other factors here, and it's 2 times 7. Okay, so I've completed step 1. Find the prime factorization for all of the numbers in question. Step 2 says, starting with the smallest prime factor, choose the number of factors of that prime that occurs the most times among the numbers in question. And so the numbers in question are 8 and 14. We're going to start with the smallest prime factor, which is 2. We're going to choose the number of that factor that occurs the most. And so in that case, I have 3 2's here. I have 1 2 over on 14. I'm going to choose the 3. And once I choose that, I need to go ahead and mark the other one so that it doesn't come into play. And step 3 simply says repeat step 2 for all primes. So once you've crossed off 2, you look to 3. There are no 3's, you look to 5. There are no 5's, you look to 7. Okay, we have a 7 here. We don't over here, and so 7, the 1 7 is the most times it occurs. Now there are no other numbers, and so we can stop. Now it says in step 4, multiply all of the prime factors found in steps 2 and 3. This is the least common multiple of the numbers. And so what I'm going to do then is I'm going to take this 2 to the third times 7. That's 2 times 2, and you can't see me, but I'm actually using my fingers here. And so I hold up one finger, that means 2 to the first, so that's 2. Times 2 is 2 to the second, times 2 is 2 to the third. And so it's 2 times 2 is 4 times 2 is 8. So 8 times 7, which is 56. And now, if you hadn't seen the previous video, our least common multiple of 8 and 14 is 56. If we go back up and view our work from previously, we will find, oh, yep, look at that, 56. And so both methods are equally valid. It's just that as you gain experience, one method will dominate the other in certain circumstances. For instance, if I'm using very large numbers, I will tend to write the prime factorization rather than multiply through. Of course, if you have a graphing calculator, many graphing calculators will in fact have a greatest common factor and a least common multiple function. So you can find it of two numbers. Okay, so we have a trial and error, we have a prime factorization method to find the least common multiple of two numbers or more numbers.